In 1995, we sent a machine into the most violent atmosphere in the solar system, knowing it would never come back. No rescue mission, no second chances, no way to retrieve it. Just one probe, alone, falling into Jupiter at 47 kilometers per second. And it had exactly one job: survive long enough to tell us what's down there. What it found changed everything we thought we knew about the origins of our solar system. And what happened to it in the end is one of the most haunting stories in the history of space exploration. This is the story of the Galileo probe. To understand why this mission was so extraordinary, you first need to understand what Jupiter actually is. Jupiter is not a planet in the way Earth is a planet. It has no surface, no ground to land on. It's a colossal ball of gas, mostly hydrogen and helium, with an atmosphere so deep, so dense, and so violent that the pressure at its lower layers would crush a submarine like a tin can. For decades, scientists stared at Jupiter through telescopes and asked the same question: what is actually going on inside that thing? We had theories, we had models, but we had never once touched it. That changed in 1989 when NASA launched the Galileo spacecraft, a mission designed to do what had never been done before: send something directly into Jupiter's atmosphere and measure it from the inside. But here's what made this mission genuinely brilliant in its design. The spacecraft wasn't one piece, it was two: an orbiter, which would circle Jupiter and study it from above, and a probe, a separate armored capsule that would detach, fall into Jupiter alone, and transmit everything it experienced back to the orbiter before being destroyed. Two spacecraft, two roles, one shot at history. About 5 months before arrival, while still hundreds of millions of kilometers from Jupiter, the probe was released. Just let go. No engines, no propulsion. It drifted away from the orbiter on a precise, pre-calculated trajectory, following a path that had been mapped out years in advance. Every calculation had to be perfect, because there was no way to correct course once the probe was released. The orbiter then fired its own engines, adjusting its path, not to follow the probe, but to position itself where it needed to be, in orbit around Jupiter, at exactly the right angle, at exactly the right time, to receive the probe's transmissions and relay them back to Earth. Think about the precision that required. Two spacecraft, separated by hundreds of kilometers, arriving at Jupiter independently, at different angles, coordinated down to the minute, one to fall, one to listen. And then, both of them went silent. For 5 months, the probe drifted through deep space, completely powered down, preserving energy for the moment it would need everything it had. As the probe neared Jupiter, something switched on. Its instruments, dormant for years, began powering up, and almost immediately they started detecting something alarming. Jupiter is surrounded by an invisible field of death. Its magnetic field is the strongest of any planet in the solar system, and it traps high-energy charged particles, electrons, protons, accelerating them to enormous velocities and holding them in radiation belts that completely surround the planet. These belts are lethal. The radiation levels near Jupiter are thousands of times higher than anything a human could survive. Electronics can be fried, sensors can be blinded. The probe flew straight through them, and while it did, its instruments were already working, measuring the energy of those particles, mapping the radiation environment, collecting data that had never been gathered this close to Jupiter before. It also started listening for something scientists had long suspected, but never confirmed: lightning. Jupiter's atmosphere is known to be dynamic. Massive storm systems, wind, bands, the Great Red Spot. But was there actual lightning? Real electrical discharge like thunderstorms on Earth but on a planetary scale? The probe's instruments began detecting radio signals, the signature of lightning. Massive, continent-sized storms crackling with electrical discharge in Jupiter's upper atmosphere. That alone would have been enough to justify the mission, but the probe was just getting started. On December 7th, 1995, the probe hit Jupiter's atmosphere at 47.4 kilometers per second. Let that number sit for a moment. That's nearly 170,000 kilometers per hour. Fast enough to travel from New York to Los Angeles in about 1 minute. The moment it touched the upper atmosphere, the air resistance was so catastrophic that the probe began to decelerate at a rate of 228 times Earth's gravity. 228 Gs. Fighter pilots black out at 9 Gs. The human body begins to structurally fail somewhere around 20. At 228, there is no biological material on Earth that survives intact. The probe was not biological, but it was still being tested to its absolute limits. The friction from entering at that speed generated temperatures on the probe's heat shield that exceeded 15,000 degrees Celsius. That is hotter than the surface of the sun. The heat shield didn't try to stop the heat. It was designed to sacrifice itself, to ablate, to burn away layer by layer, absorbing and carrying the thermal energy away from the science instruments protected inside. It worked exactly as designed. In under 2 minutes, the probe had shed most of its velocity and survived the most violent atmospheric entry in the history of space exploration. Then a parachute deployed, and here's where it gets interesting, because there was a moment, a brief, terrifying moment, where nothing happened. A wiring fault caused a delay in the parachute system, the exact system the entire mission depended on to slow the probe's descent and give its instruments time to work. For a few seconds, the mission hung in the balance. Then the parachute opened, the probe stabilized. Its instruments, battered, irradiated, having survived entry forces that would have killed anything biological, began their work. For 57 minutes, the Galileo probe descended through Jupiter's atmosphere, transmitting everything it measured back up to the orbiter waiting above. Temperature, pressure, wind speeds, cloud composition, atmospheric chemistry, radiation levels from inside the atmosphere. The winds were astonishing. Jupiter's atmosphere doesn't just move, it roars. Wind speeds exceeded 500 kilometers per hour in the probe's descent zone, far stronger than scientists had predicted from their external observations. The probe also discovered something unexpected about the water content. Scientists had expected Jupiter's atmosphere to contain significantly more water than it did. The probe found far less, a result that challenged existing models of how gas giants form and how they evolve over billions of years. And then there was the helium and hydrogen analysis. Jupiter, being one of the oldest and largest objects in the solar system, is essentially a time capsule. Its deep atmospheric chemistry reflects conditions that existed in the early solar system, which means understanding its composition helps us understand what the raw material of the solar system looked like before planets formed, before Earth formed, before life was possible anywhere. The data the probe collected that day gave scientists a window into the conditions that existed shortly after the Big Bang itself. All of this transmitted in real time up to the orbiter, which relayed it across hundreds of millions of kilometers of empty space back to Earth. The probe was built to survive pressures of up to 10 bars, the equivalent of diving 100 meters beneath the ocean's surface. It survived that. It kept going. 15 bars, 20 bars. The instruments kept functioning. Data kept transmitting. The probe pushed deeper into Jupiter than anyone had dared design it to go. At 57 minutes after entry, the signal stopped. Not because the mission failed, not because of a malfunction or a design flaw or a mistake. The probe simply ran out of atmosphere it could survive in. The pressure became so immense and the temperature so extreme that the probe's systems were crushed and overheated simultaneously. Its transmission ended, its structure failed, and then it continued falling into deeper and deeper layers of Jupiter's atmosphere until the heat and pressure became so intense that the metal and components that had once been a spacecraft simply vaporized. The Galileo probe no longer exists as an object. It exists as atoms, scattered through Jupiter's atmosphere, permanently mixed into the clouds of the largest planet in our solar system. It went in, gave everything it had, and became part of the thing it was sent to study. Here is what I want you to take away from this. The Galileo probe traveled for 6 years. It crossed hundreds of millions of kilometers of empty space. It survived radiation that would have fried unshielded electronics. It endured entry forces beyond almost anything we've ever engineered for. It fell through an alien atmosphere, measuring a world that no human eye will ever directly see, and it transmitted every single measurement back before it died. It was the first spacecraft in history to directly sample the atmosphere of a gas giant, and it remains the only one. To this day, no other probe has entered Jupiter's atmosphere. No other mission has done what Galileo's probe did. We have orbiters. We have flybys. We have decades of observations from above, but we have sent exactly one thing into Jupiter's atmosphere, and it told us more in 57 minutes than we had learned in centuries of observation from the outside. Space exploration doesn't look like the movies. It doesn't look like heroes walking away from explosions. It looks like this: a machine the size of a washing machine falling alone into an alien sky, transmitting data for less than an hour, and then ceasing to exist. And yet, that hour reshaped our understanding of the solar system. If this kind of story is what you're here for, the real science, the real engineering, the missions that actually happened, then you already know what to do. Subscribe, because there are dozens of stories exactly like this one waiting for you here. Missions that changed history, discoveries that rewrote textbooks, moments where human curiosity sent something into the unknown, and the unknown sent something back. The next one drops soon. Don't miss it.